Woohoo! Welcome to Mr. Baker's House of Knowledge. Today we're going to be learning about triangles. So it's a very important, well-known fact that the sum of the measures of the angles of a triangle are 180. So more specifically, the sum of the measures inside the triangle are 180. These are known as interior angles. So what I'm saying is no matter what triangular shape I draw, if I have an angle here and an angle here and an angle here, if I add all of those measures up to be 180 together, they'll be 180. So for example, if that angle was 60 degrees and that angle was 70 degrees, then this angle would have to be 50 degrees because 60 plus 70 plus 50 is equal to 180. If I change one of these angles, then there has to be some other adjustments made because the total will always be 180. A demonstration of why this works is if I take and draw a triangle, and it can be any shape, so I think I'll even draw an obtuse triangle here. And then if I go and if I tear off the corners, so I'm going to represent tearing off the corners by taking little pictures of the corners. So I'm going to, I need to get that smaller there. Okay, I'm going to take a picture of this corner, and I'm going to put it on the current page. We'll take a picture, I'll take a picture of this corner, put it on the current page, and I'm going to take a picture of this corner. I'll put it on the current page. Oh, I didn't put it on the current page, I'll put it on the clipboard. So it's up here. So now I've got this angle, I've got this angle, and I've got this angle. Let's make them all a little bit bigger so I can see things a little bit better. So I've got this angle. And what I'm going to do is I'm going to rotate these angles around, and I'm going to put them together to where they would all be adjacent angles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to move this one up here. I need to make that transparent somehow. Let's move that to the back. So let's rotate that around. Fortunately, when I set it in there, and then let's make this one bigger. And then I'll set it. I got to put it on the front here. So put it back. So that kind of lined up with that. So you can't see it because some of them cover up the others. But if I put all of those angles adjacent to each other, do you see how they're adjacent angles? If I added this angle up and this angle up and this angle up, they would all be 180 degrees. That'll happen no matter how you draw a triangle. If you draw a triangle and you rip off the corners, you should always be able to set them up, or cut out the corners. You should be always be able to set them up to where it's 180 degrees. So the sum of the interior angles will be 180. That's a theorem. All right, what does this mean? Well, when you have a situation like this, where you've got a bunch of variables and a bunch of angles, you can solve and find the values of the missing angles by knowing that the sum of the interior angles is equal to what? 180. So for example, I could solve for x by saying x plus 59 plus 43 equals 180. Because in triangle ABD, I have interior angles as x, 59, and 43. And I know that their sum comes out to be 180. So what I'm going to do is I'm going to combine like terms. 59 plus 43 is equal to 102. And then subtract 102 from both sides, and x is equal to 78 degrees. Does that make sense? All right. Now, I can also find the measure of angle Z, because I know that in the big triangle, triangle ABC, I know that Z is one of the angles. What's the other angle? What's the angle at angle A? No, at angle A. Here's angle A. 59. So we're in triangle ABC. I'm using angle C, which was Z, angle A, which is 59. What's the value of this angle right here? ABC. So you're going ahead and adding them together in your head. What I would do is I would just say, I know it's the sum of these two angles by the angle addition postulate. So I would just put plus 43 plus 49 equal 180. So this is the measure of angle C. This is the measure of angle A. And then these two right here were the measure of angle B. And so that all equals 180. Because the sum of the interior angles of a triangle, triangle ABC, the sum of all of its angles has to equal 180. This is definitely note card worthy. So now I combine my like terms. So I got 59 plus 43 plus 49. And when I add all those together, that's 151. And then when I subtract 151 from 180, I get 29. So Z is equal to 29. Now, if I know that Z is equal to 29, I can use triangle DBC to find Y. So Y plus 49 plus 29 would equal 180. Well, I mean, it depends on what you consider a lot of work, I guess. So Y plus 78 is equal to 180. Y is equal to 102. You want to know something interesting? What's the relationship between X and Y? They're linear pairs. What do we know about linear pairs? So I should be able to add whatever I got for X and whatever I got for Y together and get 180. 78 plus 102 is equal to 180. So the relationships always hold true. If you ever find a situation where you found an answer doing the problem using one set of relationships and it violates another relationship, chances are you made a mistake, or there's a mistake somewhere, you need to find it. Because you're not going to be able to use one relationship and it work and it break with a different relationship. So the sum of all the angles, the interior angles of a triangle equals 180. And we use that information to solve for all of these different angles. Pretty neat, huh? Yeah. All right. So there's another rule called the exterior angle of a polygon rule, the triangle exterior angle theorem. And the triangle exterior angle theorem says if you take the exterior angle, it will always equal the sum of the two remote interior angles. So now we've got to figure out some terminology here. We have to figure out what an exterior angle is, and we have to figure out what I mean by remote interior angles. So for an exterior angle, let's just draw a random triangle. Does everybody agree that that's a triangle? It is. So that's a triangle. I just drew a random triangle. How do I find an exterior angle? Well, if I take the triangle and extend any one of its sides, there's an angle formed out here. So angle 1 would be a remote, would be an exterior angle. And it doesn't matter which line you extend. I could extend this other line, and I could get this remote or this exterior angle. By the way, what's the relationship between angle 1 and angle 2? They're vertical angles. What do we know about vertical angles? They're congruent. So it doesn't matter which exterior angle I use. I could use angle 2 as the exterior angle for that vertex, Or I could use angle 1 as the exterior angle for that vertex. It doesn't matter which one I choose because vertical angles are congruent. So if I extend this line out here, I've got a different exterior angle. Yeah, seeing what's the relationship between angle 3 and angle 4? And what do we know about vertical angles? They're congruent. So if I drew this triangle and I said, give me an exterior angle at that point right there, at that vertex, it wouldn't matter whether you extended this line and used 3 or extended this line and used 4. They're vertical angles. Vertical angles are congruent, so they're going to be equal to each other. Same thing at this end. So basically what I'm saying is every triangle has two possible exterior angles at each vertex. It doesn't matter which one you use because the exterior angles are vertical angles and they're congruent. So, I now know what an exterior angle is. What is a remote interior angle? Well, first of all, it being an interior angle, where do you think it's going to be found? On the inside of the triangle. Does anybody have a television set at home? Do you have to go up to the physical TV and do stuff on the TV to change the channel?
No.
What do you use?
A remote.
A remote. The remote lets you operate the TV at a distance. Remote means the furthest angles away from, or the ones that are at a distance from, the angle that I'm choosing to be the exterior angle. So depending on which exterior angle I pick, the remote angle will be different. So for example, in my drawing right here, if I chose angle 2 to be the exterior angle, what are the two farthest angles away from, I guess I need to label these angles. So let's say inside we've got 7, 8, and 9. What are the remote interior angles based off of exterior angle 2? 9 and 8. So this one and this one. Does that? There will always be two remote interior angles. So in this particular problem, I'm saying that the sum of those two remote interior angles, 8 and 9, if I added the measure of 8 and 9 together, I would get the measure of angle 2. Based on this theorem, the triangle exterior angle theorem. If I have an exterior angle, then the sum of the two remote angles are equal to that. Very note card worthy. So we've learned two things today about triangles. Number one, if you add all of the angles inside together, it'll always equal what? 180. Number two, if I have an exterior angle, then it's equal to the sum of the two remote interior angles. So there's two relationships I can create. I can create angle plus angle plus angle equal 180, or I can say angle equals the sum of the other two angles. All right, let's see how that comes out in working problems. So we're going to use the triangle exterior angle theorem to find the values. What do you think we would do to get the first of all, what is angle 1? Is it an interior angle or an exterior angle? Exterior. And what can I add together to get the values of angle 1? And well, angle 2 and angle 3, I don't have a 2 and a 3 here, so what are the 80 and the 18? So the 80 and the 18 are remote interior angles. I can just add them together. So here's your work. 80, 18, add those together. 80 and 18 is 98. So the measure of angle 1 was equal to 98. What do you think you're going to do in this problem? Because now I have I have the exterior, and I'm missing one of the remotes. What do you think you do, Shelby?
124 equals 59 plus x.
And instead of x, I'm going to use measure of angle 2 because that's what they gave me there. How would I solve?
You would subtract 59.
So this is just a subtraction problem. So the measure of angle 2 is going to equal 65. 65. So I've shown you some applications about how to use the interior angle theorem. I've shown you some applications about how to use the exterior angle theorem. Now, let's see if we're up to doing it on our own. I want you to work this problem right here. All right, Eli, what did you do to set this sucker up?
I drew my angle or triangle.
Yeah, I think that's a great way to start setting this up. I would start out by drawing a triangle. And I know that I'm going to have an extended angle in there, so I'm actually going to go ahead and draw the triangle with an extended angle. So two angles of a triangle measure 53 degrees. What is the measure of the exterior angle at each vertex of the triangle? So this is 53 degrees, and this is 53 degrees. Now this is just a sketch. These might not actually measure 53. How do I find this missing angle? We'll call this x. How do I find x? Right. So x plus 53 plus 53 is equal to 180. X plus 106 is equal to 180. And x is equal to 74. Why in the world would I have found the value of this angle to be 74? What's the usefulness for that? Yeah, I know, but the question didn't ask me to find this. Why did I go ahead and find it? Right, because the question asked me to find all of the exterior angles. So not only do I want to find just one exterior angle with these two things as remote, but I want to find all of them. So how am I going to find this one? What's this angle going to be? What are the remote interior angles to that angle? 53 and 53.
It would be 106.
So this would be 106. For that remote interior angle, that's 106. What would the angles for this remote interior be?
74 and 53.
74 and 53. And that would give me what?
127.
127. And since this is also 53 and that's also 74, I bet that's 127 as well. All right, so the answer to this question is 106, 127, 127. Everybody okay with that?
Yes, sir.
Questions?
No, sir.
Would you not include 74 in that since you found the value of x?
So it says, what is the measure of an exterior angle at each vertex?
Oh, so you don't.
So it didn't ask me for the 74, even though I still had to find the 74.
Okay.
So I'm not going to include it in my answer, but I definitely included it in my work. All right. Let's get all pictorial here. We're going to be applying the triangle theorems. When a radar tracks an object, now by the way, let me tell you something. There is a lot of stuff that's done real life with triangles. I mean, that's how we know how far the sun is away from the planet Earth, is from using triangles and known information. So when a radar tracks an object, the reflection of the signals off the ground can result in clutter. And clutter causes the receiver to confuse the real object with the reflection. It's called a ghost. At the right, there is a radar receiver at A, an airplane at B, and the airplane's ghost at D. What is the value of the angle X? So I obviously don't want to know about the ghost under the ground, but I might want to know what this angle is right here. So how would I go about finding this? So I've got an interior angle, I've got an interior angle, and I've got an exterior angle. And the exterior angle, I know because of the ghosting. Yes?
So it's 30 plus x equals 80.
So 30, the interior angle, plus x, the interior angle, equals 180.
No, just 80.
Oh, just 80. And 80 is what? The exterior angle?
Yes.
Okay, I'll go along with that. That works for me. So how would we solve?
Subtract 30.
So we'd subtract 30 from both sides, and x is equal to 50. So I now know that that's 50. By the way, what would this interior angle be?
100.
100, because 100 plus 80 is 180, or 50 plus 30 plus 100 is 180. Either way you figure it, it works. All right.